And we'll go ahead and get started here. Good morning, everybody. You're doing some excellent words of wisdom. You would be wise to remember this. Victorious warriors win first and then go to war, while the defeated warriors go to war and then seek to win. The difference is planning, preparation, right? Knowing what it is you are going to do before you go out and do it. So that's my advice for you today. Have a plan in place. All right, so my plan for today when it comes to geometric mathematics is dealing with surface area. Okay? You got to read all about it this weekend, all about that surface area and volume. I know it seemed like a lot, and I found the most condensed, packed-in text I could find that still had some examples, okay, if you needed to see that. But it all comes down to this. Right there, this whole thing. This reference, this is the actual reference sheet you will have on the SAT. It is at the beginning of each of the math sections in the booklet. They give you the formulas, folks. Most of all that reading was, oh, here's the formula for this kind of shape. Here's an example of its use. Here's the formula for this kind of shape. Here it is, an example of its use. The actual process of calculating any of these things is very straightforward. Here's the shape. Figure out which kind of shape is it? Which formula do I need? Which measurements have they given to me? Put them in, calculate the answer. It doesn't get a whole lot more complex than that, even on the SAT. They're relatively straightforward. So, am I asking you to memorize all of these formulas? No. Just like the SAT, if they give you all of these formulas, I will be giving you all of these formulas, okay? Our test, at the end of this semester, you will have this exact reference sheet available on it. Of course, you also have your own notes that you can reference on the test. So you should have the formulas there. So there is no excuse for you to not know how to find the area of a triangle. Okay? It's right there. Now, should you memorize these formulas anyways? Yes, you probably should. It will save you a lot of time and heartache if you just know them already and you don't have to stop and look it up every time. Like, oh, it's a triangle again. Oh, what was the triangle one? Flip, 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 flip. Where did I put those? Okay? It's going to save you a lot of time, especially on standardized tests. Time is everything. Okay? So the more you work with these, the more you use them, the more familiar they will become. And I hope that they become memorized quite naturally. And you're not just going to sit through there with like flashcards of the area formulas. But if you want to do that, you may. So today we're talking about surface area specifically, which means you can ignore this lower half for now. We'll get back to that tomorrow. And surface area, as the name implies, always begins with area. That's all it is. It's just the areas of all of the surfaces on a shape. Okay? The number one most common question is, how much paint would it take to paint this thing? And they present you an object and it's some funny shape. You have to find all the surface area. Well, if surface area is just area, then what we need to do is know how the most common shapes break down. If you can find the areas of circles, rectangles, and triangles, which I know you already should, you've been doing it possibly since 3rd grade, thereabouts. I've looked at curriculums there, it's usually about 3rd grade, where you get to see some of these things. And just about every year since. And they're given to you right here. No excuses. So let's break down some of these three-dimensional structures that we've already talked about. You've read about. This was another reason the weekend's notes was a little bit long, is it had to start out and present, hey, here's a prism. It's defined as this. We already did that. Okay, so it was a bit redundant. polygon. Okay, there you go.
Carry on, pretend. Well, I'm probably
You're probably blocking it. Yeah, yeah. Other than that, it was okay. All right, Ms. P needs some batteries. Anyways, so we're just going to break down what those three-dimensional shapes are made of, which we kind of did when we were defining them, so that you know what you need to find the area of. Okay? A prism is always made of, as we know, two polygons. Oops. Two polygons and a whole bunch of rectangles. And we keep polygons general because you could have a triangular prism, you could have a square prism, right? Have any number of different bases for that. So if you can find the area of its two base polygons and the area of the rectangles, you just add them all up and you find the surface area. That's it. Pyramids, similarly, we said this already. Bye, Ms. P.
Bye. You're probably really scared.
You've got one polygon and a whole bunch of triangles, right? All those lateral faces are triangles. So then you look up, okay, what was the triangle formula, right? Make sure you have the information for that. Any question that asks you to find the surface area of a pyramid or something, knowing triangles are required, it will give you the necessary information. We'll look at an example in a moment. Okay. And then cylinders are made up of two circles and one big rectangle that wraps all the way around the outside. Okay. And that's probably the trickiest one because the length, if you will, of the rectangle, the wrapping around dimension, that is the circumference of the circle. So you will actually need both of these formulas, the area and the circumference of the circle formula, to find surface area of a cylinder. All right, with me so far? That's the breakdown. Now, there is one minor catch here. As I mentioned, what information is actually given. So here is our worksheet for today. And we've got, here's a lovely pyramid. Look at this guy. Base is a regular hexagon. So we need to find the area of the hexagon plus all of the triangles. And since the base is a hexagon, there would be a matching number of triangles, namely, gentlemen, shout it out for me. What? How many triangles there? 6, right? 1, 2, 3, 4, 5, 6. Hexagon has 6 sides, 1 triangle per side. So you've got 1 hex plus 6 triangles, right? And notice what they've given to us here. They've given us S. Okay? And if you look at this triangle over here, this is it's a regular hexagon. So all the sides are the same. So this is also S, or 6 as they give it to us. And they give us L, the lateral height. Right? They give us that amount. They don't give us from tip to center. They don't give us the height of the pyramid. Okay? Imagine this was, let me get my 3D model here. All right, I've only got a square-based pyramid. You have to bear with me. The cheap sets don't come with the hexagonal ones. All right, it's not the height. If I wanted the height, I would measure from the center of the base straight up. Right? I would want to know how tall it is, distance between my hands here. But instead, they give us the slant height, which is along the face. But it's still at the base and perpendicular. Notice they have the little perpendicular mark here. Okay? Which means if you were to lift off that piece there, just take this one triangular face, you would have a nice, big, tall isosceles triangle with base S and height L. Okay? So you could use those values to find the area of your triangular face quite easily, as long as, so just make sure that they give you the proper one. You've got to have the height of your triangle, and the height has to be perpendicular to a base, one side of the triangle. If it's not, you've got the wrong length. Okay? This length out here doesn't help you. Now keep that in mind. Because the next tricky thing, especially with this, is how do you find the area of a hexagon? Mr. Apple, hexagon is not on my reference sheet here. What am I going to do? We're breaking it down even further. When in doubt, reduce to smaller pieces. Regular polygons can be thought of as made of, what's the simplest possible shape? Remember when we looked at the diagonals and finding the interior angles? What did we break all the polygons into? Triangles. Every polygon is made of triangles. And in the case of regular polygons, well, we get even better. We get isosceles triangles, which is pretty handy. Now, here is an example how we're going to use this, because we're not just going to draw any triangles. We want to draw from the center. We're going to slice it up like a pie. Okay? Area of a polygon, slice it like a pie. So to find the area of a regular pentagon with apothem of 2.1, that was a new vocabulary word. That was in your reading this weekend. I hope you wrote that down. And side lengths of 3 inches. Okay, side lengths of 3 inches, we know that part. That's these guys out here, right? That guy's 3, that guy's 3, that guy's 3, good. And what we're going to do is we're going to chop this up from the center point to each vertex. Oh, come on, give me a straight line. Thank you. I like a pie. Pretend you're playing Trivial Pursuit. That was a board game back in the day. It had little plastic pieces wedged together. Anyways, all right, slice it like a pie. Now, if it's a pentagon, it has 5 sides, which means there are now 5 triangles, right? So it's going to make it very easy. We're always going to have the area of some polygon n is going to be n times the triangles. So in our case, the area for our pentagon, 5 times area of a triangle. Check back to your reference if you don't remember. 1/2 base times height. Okay. Here is our triangle. I know one of the side lengths is 3. Hey, that would make a really good base, wouldn't it? But what's the height? The only other thing I'm given is the apothem. And the apothem of a polygon, let's use a different color here, goes from the center to a side, and it meets it perpendicularly. That is our apothem. That's pretty convenient, because it turns out if you slice this up like a pie, just like this, the apothem becomes the height of our triangle, which means we can fill in that value there. Let me go back to formula version. We'll rewrite this. In this case, we have 3 times apothem A 2.1. Okay? So go ahead, multiply that out. 3 times 5, 15 times 2.1. What would you rather do? Let's see, 5 1, 0, 2 times 5 is 10, 2, 3, 3, 1, 5, move the decimal point, 31.5. Divide by 2. 31.5 divided by 2. Let's see, 30 divided by 2 is 15. 1.5 divided by 2 is 0.75. 15.75. All right. There's the area. Now, that way will always work. Okay? When in doubt, break it into triangles. Find the area of the triangle, multiply by how many. Now, if you are interested in shortcuts, if you're the person that says, hey, I really want to memorize those area formulas, it'd be nice if there was a more general formula for polygons. Stick around. Okay? If you're not interested, go back to the top, start on some of the other problems. Okay? I'm going to talk how we can generalize this to make a nice, clean, simple formula for any polygon. Since we know we're always going to multiply by the number of sides here, what I can do is, if this is our base of our triangle, is the side S of our polygon, always. Then we can say this is always equal to number of sides times 1/2 times side length times the apothem. And the number of sides times the side length for a regular polygon is the perimeter. That's the distance all the way around. We go 3 inches in each direction. Oh, speaking of inches, do make sure we're dealing with area. This is inches squared, right? Watch those units. But n times s gives us the perimeter. So the area of a regular polygon could be thought of as equal to 1/2 apothem times perimeter. And the thing you just need to remember there is, what's the apothem? Is it given to me? Because if it's not given to you, then you have to calculate it. And the way to calculate it involves a bit of trigonometry, if you're unlucky. Okay? But we'll talk about some of those shortcuts next week. Okay? I think. I'll double check my schedule. When we get to the triangles unit, which I believe is next week, then we'll have a tool to calculate an apothem if it is not already given to us. Okay? But there is your general formula, if you like general formulas. 1/2 apothem times perimeter. And I think that one was actually in your, or at least appeared in your notes in one of the examples. All right, any remaining questions on surface area? Find all the areas, add them up. Now, I will make a note of number 8 here. Watch out, okay? Once again, think about if you were to cover this thing in paint. And I mean completely cover, inside, outside, anywhere a brush could reach to. So you've got the outside of the can, the top of the can, the bottom of the can, and inside each of those holes in there. Got to get the inside faces. Got to paint that too, okay? But you're not going to paint, right, the square opening. That's not there. So the very top is a circle with a square hole in it. You only need this much. So surface area is not just about adding them all up. You got to also watch, when do I subtract? Okay? Once again, third third grade skill, adding and subtracting numbers here. You can handle this. Don't overthink these things. All right. Well, this one has done a nice job of shading it for us. So you can see the circle part here is kind of a light gray, and the square there is pure white. So yes, we will assume that hole goes all the way through. The bottom also has a hole in it. Excellent question. And they'll usually be pretty good. Like the SAT will, I have seen ones where they have something here, and then they've got the hole in it, and it doesn't go all the way to the bottom, but they do like specify and say, oh, this is, 2 inches from the bottom. And they'll tell you how thick the bottom is or something. That's usually in more of the volume questions. So yeah, if it goes all the way to the end, we're going to assume it goes right through. Okay, any other questions before I leave you to it? They're shaking their heads. Anybody in chat? No? All right, then I'll leave you to it. You've got 23 minutes to go.